Hello everyone, this is Hong. I'm when you watch this video, I should be in Germany for a conference. I'm sorry that I cannot make it to this tutorial, so I need to record a video like this so that you can have some idea how to do the problem set number 4. Actually, the problem set number 4, you don't need to hand in it by next week. The due date for this assignment is the next week, so you don't need to be hurry. So, and also, if you still have problem with this assignment, you can ask me next week. I will be come back by next week. And then also in this video, I will just go through how to do task 1 and maybe some task 2. And I will not cover task 3 in this video, because task 3 is about some complex probability calculation that I think it is much better to do it in class next week. So the purpose of this tutorial or purpose of this assignment is to let you familiarize yourself with the terminology of the probability. I promise you that this assignment is not that difficult. Just some very brief calculation about probability, but you need to know something about the terminology and also some symbol so that you know what they mean. In the future, maybe in the exam, you will ask how to calculate those probability just by those symbols. So you need to know what these symbols mean. And also, okay, it's a little bit thinking forward. The task 3, the question like task 3 is very popular exam question. I just use a exam question as task 3, and so you need to know how to do question like task 3. But don't worry, I will talk about it next week. For this week, we will just do the task 1. Task 1, we will use the Titanic dataset. Titanic dataset is also available in this GitHub repo, and you can download it like we do in the previous data. We have used a CSV before, and we can just download it and maybe put it in the desktop. And then open it with Excel. This computer is not as powerful as the one that we use in the lab, so it may be a little bit slow, but anyway, it works. Okay, when you open the data file, it actually is the data of all the passengers on the Titanic. You know Titanic, right? That you jump, I jump, my heart it will go on, that movie. But I'm talking about the actual data, the actual event, so that you will not see Ross and I can't remember the name of the character that Leonardo DiCaprio played. I really can't remember. So you will not find those names on the on this data set. This data is real, so yeah, the real event. As you may not know, Titanic is something like 100 years ago. It's an accident that a big ship crashed into a iceberg, and then it sank, and then many people died. And this data set have all the passenger data, including this computer is so slow. Anyway, try to make it work. Go back to the first row. Okay, the first column is pre-class, meaning passenger class. There are 3 classes in the Titanic: first class, second class, and third class. The first class are for those rich people, and the third class are for the poor and for the workers on Titanic. And survived, meaning that particular passenger has survived the accidents or not. 1 meaning survivor, 0 meaning die in the accident. I'm sorry for this lady, Alison Helen Lorraine. And the third column that we need to concern is the sex. Is self-explanatory, meaning female meaning female, and male meaning male. Self-explanatory. So let's go back to the questions. We need to calculate those probability, right? And in order to calculate the probability, you need to know the event and also the sample space. In this assignment, most of the time the sample space is all the passenger, and the event is the probability, meaning the event here. For example, we can calculate the first one, meaning the probability of survive equal to 0. You can do it by using a pivot table, and this computer is really slow, but anyway, we can make it work. We know that our data has 1, 3, 1, 0 row. So A1 up to A10 will select all the data from the P class, but we want to select the survive, so it should be B1 up to B1310. It should be all the data, right? Yeah. And then we can go to data. Actually, we just create a pivot table that to do the counting, so you don't need to count it by yourself. And you can just drag the survive in the row labels, and then drag this one as well. But we are not wanting it to be the sum, we just want it to be the count. So we know that the survivor is 500, and we can also get the column probability, column percentage, in a column percentage. Okay, you can see that the column percentage for the survivor is 38.2%. The 38.2% is actually is calculated by this 500 divided by 130 okay, it's 38.2%. okay, 500 is the number of events, and 130 is the your sample space, and we can calculate the probability like this using a pivot table. Okay, so we get the first one done, and then the second one is very similar. We can do it very quickly. D1 up to D1310, and then create a pivot table. Like this. Okay, because the values is female and male, you don't need to change it to count. It's automatically become a count. And then show the column percentage. You get a similar number. Okay, the next part of the assignment is to calculate the union and the intersect of two events. When you refer to the lecture notes, the union of two events is defined as this equation, and this one is the intersect, and which is the reverse cup, and if you need to convert those reverse cup, union, intersect into a human language, the union is actually the OR case, and the intersect is the AND case. And as you can see, if you need to calculate the union, you need to also calculate the intersect first. So I will first go through how to calculate the intersect, and then we will do the union. The question 5 is to, okay, I mean 4 is to calculate the intersect between the event of sex equal to female and the passenger class equal to 1. So we need to calculate the probability of sex of female, and also the probability of the passenger class equal to 1. So we can do this calculation using the pivot table, and we can do it very quickly. Okay. And first is the gender. and I only want to have the probability, so I don't need the word count. So the probability of female is 35.6. So we can type it here. 356. And then the probability of class equal to 1. I want it to be the count and also the column percentage. So the P class equal to 1 is 2468. 2468. And then we can use these two numbers to calculate the intersect and the union. So the probability of female and pre-class equal to 1 is equal to this one times this one, and then we can calculate the union. Which is equal to this one plus this one minus this one. And then you get the answer for 3 and 4. Okay, we have a technical difficulty, meaning some kind of bug, so that I need to divide the video into 2 parts. This is the part 2, and in the part 2 I want to do the task 1, question 5 and 6. So let's do it. Okay. This is the formula for the condition probability, but I want to do it the Excel way, meaning using the pivot table. And first you select all the data like this, and then using the data and then insert a new pivot table. We want to create a contingency table. Okay, last week you know how to do how to construct a contingency table, and this week we use it to calculate the conditional probability. I drag the survive into the column, and then the gender into the row, and then also the count. Okay. This table, you can already calculate those conditional probability. Okay, for the first one is given a passenger is a survivor. How many of them are female? Okay, given who is a survivor, meaning this column, right? The total number of survivors is 500, and 3 of them are female, so it can be calculated as 3 divided by 500. This is the first probability that we want. The second probability that we want is given somebody is survive, how many of them are female? Okay, this one, given somebody is a female, meaning this column, there are 466 females. How many survive? That's 3 line, so it should be 3 line divided by 466. As you can see, these two numbers are different. This is the most important point that we want to stress in this course. This one is so important, so I want to stress, make emphasis once again. Remember, these two probabilities is different, even though they are just the reverse. It's totally different from the case of union and intersect. The conditional probability, if you reverse it, they are different. They have different meaning. If you need to convert it back and forth, there is method for it, but we will cover it in the next tutorial, so stay tuned. And the one final thing that I want to show you is that this method we are using is actually the same as the method that the Wikipedia told you. Okay, the Wikipedia saying that the probability of A given B is equal to A and B. The probability of A and B divided by the probability of B, right? This is the formula provided by the Wikipedia. And for example, we want to calculate the probability of survivor given female. So we can first calculate the probability of probability of S and female, survive and female, right? Which is equal to survivor and female is this number, 3 line, divided by the 130 line. And also the probability of B, meaning the probability of female, is equal to 466 divided by 130 line, and then we can divide this number by this one, which is the same as our previous calculation, if you remember. So I want to show you that the method is actually equivalent. It's actually equal to given somebody is female, right? How many of them survive? So this number divided by this number. So the number is the same. So I want to show you that our method is equivalent. So this is the part of the conditional, how to calculate the conditional probability. And finally, okay, if you know how to do the 5 and 6, you know how to do the 7 and 8. And finally, the question asks you, do you agree the female passenger on Titanic have a higher survival rate? Okay, if you do the raw calculation of the survival rate among female, we did that here. Given somebody is female, how many of them survive? The probability is 7 to something. So, but we also know that the passenger class also affect the survival rate. So we want to further stratify this table by the passenger class. So we can we did that last time, so it is actually the same. So we just add one more variables into the vote label, and then also calculate the probability. The percentage of vote. Okay, how many of them die? And using the knowledge you know from last week, you should be able to know how to make the correct judgment about it. So I don't want to repeat it. So you can deduce it by yourself. And this is actually the end of the video. The second part is quite similar. It's just